In 6.2, we're going to be working on comparing and ordering integers. When we start comparing the integers, this is going to be the most important thing that we continue to come back to, and that is that on a horizontal number line, numbers to the left are always going to be less than or smaller than any number to the right. We already know that numbers to the left of 0 are going to be less because they're negative, but even when we start comparing one negative number to another negative number, if you picture them on a number line or actually draw out a number line, any number on the left would automatically be less than any number on the right. And so we usually kind of remember that by saying left least. So left least numbers, and we'll practice that in a couple of examples. For example 1, we're going to compare integers on a horizontal number line. So the question asks us to compare 2 and -6. So when they say compare, they're usually talking about less than, greater than, or equal to. So the first thing we're going to do is draw a small number line. So I've got a number line here, and the better you get with integers, the easier the number lines will get because you can decide your starting and ending points. Obviously, we have to make sure that the number line includes 2, which is over here, and -6, which is down here. So the only other requirement, remember, is that it has to count in equal intervals. But notice I started at -6. I didn't go all the way up to +6 just because I was running out of room and I wasn't going to need a number that high. So these are still considered equal, even though 0 is not really in the middle, because we still counted by an equal interval. So again, you'll get used to that, and that's fine as long as you're counting in equal intervals. But when we do this, we said the best way to compare them is to picture them, or in the first couple of practice problems, literally draw them onto a number line. And so if we look at where -6 is, that would be down here. So we're going to put a plotted point at -6, and then 2, because it doesn't have any sign in front of it, is obviously a +2, so we're going to put that there. And we did say left is going to be least, so anything to the left will be smaller than anything to the right. And so in this case, since -6 is to the left, then we can say that is less than 2, but we do have to compare it in the order they gave us. So you kind of want to picture it in that order, 2 compared to -6. And so since -6 is the least one, then that must mean that 2 is the bigger of the numbers. So we write 2 is greater than 6. And again, we have to do that because we have to go in order from left to right, just like we would read in a book. We read math problems from left to right in this case. So we would say 2 is greater than -6. If we look at vertical number lines, then any numbers below or lower on the number line are going to be less than any numbers above. So that means any numbers towards the top or above on the number line are going to be greater than anything below. For example 2, they're asking us to compare -5 and -3. And again, at first we're going to quickly knock out a number line, and in this case they're talking about vertical. And I did start it at 0 this time because I'm working with both negative numbers, which means the smaller numbers are going to go down. So I went from 0 to -1 to -2, kept counting by equal intervals, and then I'm going to plot those. So -5 would be down here, and -3 is right here. And according to our key idea that we just wrote, any numbers below or lower on the number line are going to be less than any numbers above. So in this case, again, because we have to go in order least to greatest, -5, oops, that's a bigger one, and then compared to -3, when we look at them, since -5 is lower, that means it is less than -3. Here are a couple of on your owns to try. And there would be the way you would correctly fill in those statements using the greater than, less than sign. In example 3, we're going to be ordering integers, and they ask us to order this set of numbers from least to greatest. You always want to watch and see what order, because every once in a while they'll throw a curveball and ask you to go from greatest to least, but usually they'll go least to greatest. And the thing you're going to want to be really careful about when you look at these is checking your signs carefully, because it's easy to miss one, and then you could end up putting it in the wrong spot. Other than that, the first step is going to be to graph or to knock out a quick number line so that you can graph these. So your number line could look like this. Again, you could have started it at a different spot as long as you get all of these numbers on there and you count by equal intervals, that's fine. And then we can see we're going to put -4 on there, so that's down here. 3 doesn't have a sign in front of it, so it's positive. 0, and then -1 and -2. And then once we do that, ordering them is easy because left is least, so we go from least to greatest, meaning anything on the left is the smallest, and then we just work our way up. Whoops. I'm just going to work our way up to the right. So our final answer for this one would be -4, -2, -1, 0, and 3, because -4 would be the smallest, and then +3 would be the greatest in this list. Example 4 is a little bit unique, so I want us to reason through it. So it's called reasoning with integers. And the question says a number is greater than -8 and less than 0. And what is the greatest possible integer value of this number? So again, we're looking for the greatest or biggest possible integer value. And the only reason they stress that is because, as we've learned in the earlier sections of chapter 6, integer has to be a whole number. So we were trying to figure out what the greatest possible whole number, positive or negative, would be in this range. They gave us some multiple choice options, so it could be any of these. And the best way to do this is to start with a number line again. This one ends up being a little bit of a bigger number line because we have to go all the way from -8 up to 0, and a lot of times we'll go 1 or 2 above and below those just to make sure that we have room on our number line, counted by equal intervals. And then we're going to find our range here, which we should know is the difference between our biggest and smallest numbers. So if it's going to have to be somewhere between -8 and then 0, we can kind of see that this is the range we're working with here. So it'd be anywhere between here and here. And they say that we're looking for the greatest possible integer. And since we've learned earlier that the left numbers are going to be the least, anything down here would be the smallest possible. And then working our way up to the greatest possible options. So if we're looking for the greatest possible integer value that is less than 0, then the greatest possible integer less than 0 would have to be right here. Oops, right there, because it's the closest number to 0 within this particular range that we were dealing with. So according to our multiple choice answers, that works out for us because -1 is one of the possibilities, and that is exactly what we thought when we put that on a number line. Go ahead and try this on your own. Order them from least to greatest.